if you get below 90. If you get below 90. Hello everyone, this is Science Professor Obene. Welcome to the channel. If you haven't already subscribed, subscribe. Okay, this is Science Professor Obene. Alright, like the pages and also share the pages. Today we are going to look at the Sun, Earth and Moon systems. The Sun, Earth and Moon system. This is almost everything that you will need for the Sun, Earth and Moon system in order to do well on the intermediate science exam for middle school. It will also be helpful, for you, those students in high school also. So today we are looking at the Earth, the Sun, Earth and Moon systems. Okay, so let's start off by talking about the solar system. So when we talk about the solar system is the sun and a group of objects that move around the sun. So the solar system, at the center of our solar system, we have the sun. We have other planets that orbit around the sun. Okay, so that's the solar system. When we look closely at the solar system, the sun is the largest object in our solar system. It's over 1 million times greater in size, volume, and also than the Earth. Okay, so if you compare the mass of the sun to that of Earth, the mass of the sun and also the volume of the sun is over 1 million times greater than that of Earth. So that means that the sun is very, very massive. The sun is very, very big. It's huge. The mass is make up about 99% of the mass of the entire solar system. So that means that the sun is very, very, very big in our solar system. The mass of the sun alone is about 99% that of the entire mass of the solar system. Okay, so there are other objects in our solar system. Besides our planet, there are other objects in our solar system. And these objects in our solar system, they include comets, asteroids, and dwarf planets. All these objects, they all revolve around the sun. They move around the sun. Okay? So, one will ask, what keeps these objects in orbit around the sun? Why don't, these planets fall off? What keeps them in place that they're able to revolve, constantly move around the sun? And what keeps these objects around the sun is what we call the gravitational force or gravity. Force of gravity is what keeps these planets to move around and also orbit the sun. It's because of the force of gravity. That's why the object that moves around the sun, they don't fall off. These planets, they are in constant orbit. They move around the sun without falling off. It's because of the force of gravity. Okay, so when we talk about force of gravity, it's an attractive force between two objects. Any two objects in the universe that has mass, there is a force of gravity between any two objects in the universe that has mass. Okay, and the factors that affect gravitational forces, they include the mass and also the distance between the objects. The greater the mass, the greater the gravitational force. The greater the distance, the less the gravitational force. Okay, so if you look at the gravitational force equation, gravitational force F is equal to gravitational constant times the mass of one object times the mass of the second object, all divided by the distance of the square of the distance apart between the two objects. So if you increase the masses, you are increasing the gravitational force. If you increase the distance between the objects, you are reducing the gravitational force. Okay? And moving on, we are looking at Earth systems. The Earth is a system on its own, and it's also part of the solar system. So the Earth has 4 systems or spheres. The Earth has 4 spheres, and these spheres, they include the hydrosphere, atmosphere, geosphere, and biosphere. The atmosphere is a mixture of gases that surrounds the planet. So this is the atmosphere, a mixture of gases that surround the planet. The hydrosphere, remember hydro means water. Hydrosphere is all the liquid water, and ice on a planet. Geosphere is a solid part of a rocky planet. Geo means from the ground. Geo means solid, the solid part, the rocky part of the earth. Remember, geothermal energy is energy from the ground. So geosphere is a solid part of the rocky planet. And finally, we go to the biosphere. Remember, bio means what? Bio means life or living things. So biosphere is all the living things on the planet. And now we are going to take a closer look at the parts of the Earth's geosphere. So, these are the parts of the Earth geosphere that you should know for intermediate science exams. So we have our geosphere, which is the solid part of the rocky planets. So we have the inner core, which is inside the geosphere. Then after the inner core, moving outwards, we have the outer core. Then we have the mantle. Then we have the crust, the earth crust. So these are the parts of the geosphere that students, young scientists, you should know about. So now we are looking at period of rotation and period of revolution. When we talk about period, what is period? One can ask you, what period do you have science? Or what period do you have ELA? So period simply means what time. All right? Period simply means what time. Okay? So when we talk about period of rotation, period of revolution, that means what time or how long does it take for the Earth to revolve, for the Earth to complete one rotation. All right? So here we are looking at the effect of Earth's period of rotation and period of revolution on the length of one day and a year. So when we talk about period of revolution, is the time it takes an object to travel once around the sun. So period of revolution is the time it takes the Earth to move once around the sun. That's a period of revolution. How long it takes the Earth to revolve around the sun. Okay? And when we talk about rotation, period of rotation simply means how long or how much time it takes the Earth to complete one rotation. Rotation is the spinning of Earth on its axis. The Earth spins on its axis whilst it also revolves around the sun. It takes 1 day for the Earth to complete one spin on its axis, and that's what determines the length of day. So the length of day is 24 hours. So every 24 hours, the Earth completes one complete spin or one complete rotation on its axis. And every year, the Earth completes one revolution around the sun. That's what determines the length of year. So revolution is about how long it takes the Earth to orbit the sun. Rotation is how long it takes the Earth to spin on its axis. And it takes 24 hours for the Earth to complete one rotation on its axis. It takes 365 days for the Earth to revolve around the sun. So this is revolution. Okay? Going around the sun is Earth's revolution. And that takes 365 days. So here we are looking at what causes or what determines seasons. We know that the Earth is tilted at an angle of 23.5 degrees. So what causes seasons on Earth is the Earth's rotation on its axis. The Earth is tilted on its axis at 23.5 degrees. So the tilt is what causes seasons on Earth. And also the revolution of the Earth around the sun. These are the two things that causes seasons on Earth. Okay? So if you look at the Earth revolving around the sun, okay, in December 22nd, we can see that the Earth is tilted, it's always tilted at an angle of 23.5. But during December, if you look at the North Pole here, the North Pole is tilted away from the sun. So the North Pole is not receiving enough sunlight compared to during the summer. All right, there is not direct sun rays hitting the North Poles. That's the reason why during this time we have winter. Okay, and during June too, the tilt of the Earth, the North Pole is facing the sun directly, almost directly. And that's the reason why we have summer during this time. Okay, so what determines seasons on Earth are two main things. The first one is the tilt of the Earth. The second one is the revolution of the Earth around the sun. So please do not forget what causes seasons on Earth. Tilt and also revolution of the Earth around the sun. Why is the equator warmer than at the poles? That's a question, we need to be able to answer. Why is the equator warmer at the poles? So if you look at the image right here, we see that we have the equator here. The equator is an imaginary line that divides the Earth into two poles, the North Pole and the South Pole. So why is it that the equator is usually warmer compared to the poles? And the reason is so simple. If you look at the amount of sun rays hitting the equator, the amount of sun rays that hit the equator is almost at a 90 degrees. So at the equator, the sun rays hit the equator directly compared to the poles. And because the Earth is curved, at the poles, the sun rays, they are more spread out at the poles. So at the poles, there is not greater sunlight intensity reaching the poles compared to the equator. That's the reason why at the equator it's much warmer compared to the poles. Okay? So here we also see a different diagram showing why the equator is warmer compared to the poles. Because at the equator, sun rays, they hit the equator directly. At the poles, it's more spread out. So low intensity of incident rays at the North Pole. And also because the North Pole is tilted away during this time, which is in December. So whilst there is winter in the North Pole, South Pole, they have summer. Okay? So we're also looking at sunlight striking the equator compared to the poles, different angle. So the sunlight striking Earth near the equator is direct sunlight striking the equator. So we have small area and the same amount of sunlight is striking the equator. If you look at the poles, sunlight striking near the poles is much spread out because the Earth is curved. And that's what determines the intensity of sunlight or sun rays reaching the place. And remember that the amount of sunlight reaching an area, that's what determines the air temperature. So compared to the sunlight that strike near the equator, the sunlight that strike near the pole are spread over large area. The difference causes sunlight that reach the North Pole to be less intense than the sunlight that reaches the equator. Okay? So the sunlight that reaches the equator is more intense because it's hitting the equator directly. All right? So that's what causes the amount of sunlight, or that's what causes the warmer area at the equator compared to the poles. So the equator is more warmer compared to the poles. Okay? So what determines seasons, length of day, and length of year? All right. So if you look at this diagram here, the Earth is tilted. So at this point, it means it's in December, there is winter in the northern hemisphere. So Earth's rotation on its axis takes about 24 hours. Earth's rotation defines the length of day to be 24 hours. Earth completes one revolution around the sun every 365 and a quarter days. Earth's revolution